The last video was devoted to the need for airline pilots' participation in air accidents investigation. We continue our story about the way we have managed step by step that the opinion of pilots in Ukraine was heard in every investigation of aviation accidents. Along the way, let's touch on the specifics of the work of an air traffic controller, and as a bonus, you will learn how the environmental rebound effect works. Our regards to Gretta Tumberg. One video, one case, one investigation. July 15, 2013. Kyiv Airport, Zhulyany. It was a wonderful weather, good visibility. At noon, the Boeing 737-500 of Russian airline UTR Flight 797 overran from the runway surface. In aviation terms, it's called runway excursion. No injuries were reported. The plane remained intact and undamaged. The airport was closed from 12:15 to 14:55. For the first time, a line investigator pilot was called in to investigate this incident. And the question immediately arises, why? In this case, it was necessary to bring theory and practice together to compare the calculated characteristics of descent, approach, and braking distance on the runway with the actual ones. And so, the investigation goes on. The flight parameters were deciphered, interviews were taken with all crew members. Pay attention, not an interrogation, not an explanation, but a regular interview. No accusatory BS. The crew passed an alcohol test successfully and flew away on their own return flight as passengers on another plane. By the way, the procedure for a crew to pass an alcohol test after an incident is not mandatory, and in subsequent videos you will see that investigators gradually stopped abusing this procedure. The further work of investigators is the analysis. The standard way is the reconstruction of events. We are moving from a complete stop of the aircraft on the ground to the beginning of the approach and look at where exactly something went wrong. How does an aircraft make an approach? There are special approach procedures developed specifically for each airfield. These charts provide, among other things, safe intervals between aircraft in the air and on the ground during peak loads. When there is no high intensity, it is absolutely safe to shorten the route. In this case, the air traffic controller makes decisions on many tasks. Only he knows the actual situation in the air, the relative position of the aircraft, the ability of the airfield to safely manage the inbound traffic at a particular time. Air traffic controllers are professionals of the highest level, because it is necessary to calculate the straightening of the route in a split second and at the same time ensure safe separation. It is not enough to take into account the relative position of aircraft, it is necessary to know the performance of each. How quickly a Boeing, Airbus or for instance Cessna can reduce speed, with what vertical speed a particular aircraft can descend or climb. All this is in the head of the dispatcher. Computers are not yet able to cope with tasks where there is no algorithm where changes in the flight trajectory are instantly calculated. On July 15, the intensity over Kyiv was not high. The controller gave a shortcut to the flight 797 to enter airspace of Zhulyany airport. Distance, speed, time. The basic formula for a pilot. Distance. The controller, in our case knowing the performance of the Boeing, reduced the distance. Speed. The speed remained the same. After all, the controller reduced only that part of the approach in which the speed would practically not change. Time. Time to landing has decreased, which means that the amount of fuel burned has decreased. Watch the video to the end and you will see how the ecological rebound works. The operating time of the airframe, engines and aircraft systems also decreased. The time of post-flight maintenance of the aircraft, the stopover time, has increased, which is fine for the next flight. Operating costs are reduced and profits are increased. Everyone is happy and with benefits at the same time. So, the Boeing 737 Flight 797 continues its approach to Zhulyany on a new descent profile. The controller got the picture in his head. Everything is normal. There is enough time to complete all procedures for safe approach. After recalculating the descent profile in an aircraft computer, the picture is the same. Everything is going on perfectly fine, as briefed before, until When entering the long final, the plane is slightly above the profile, which in itself is not critical. It is critical that the speed exceeds the calculated one by 40 knots. Speed, distance, time. As the tutor of aerodynamics at the flight school told us, that's as simple as mathematics lessons in grade 5. Not only the time to landing has decreased, the time for decision making has sharply and instantly decreased. Before the turn it was a normal flight, after the turn a critical situation. Looking ahead, I want to reassure you that when it comes to flight safety, the so-called risk factors are taken into account. These factors can arise, develop, intensify and dissipate. Sure, risk factors can also dissipate and disappear. July 13, 2013, 11:56. UTAIR's Boeing 737 is approaching to the short final above the required descent profile with an increased approach speed. The controller notices the deviation, warns the crew, but the lack of time takes over. The pilots become automatic robots that correctly and consistently perform procedures one by one, forgetting about the need to make decisions. Landing gears down, confirm. Flaps 15, confirm. Flaps 25. The speed is still above normal. Right now you can extend flaps for 25. Flaps 30, confirm. Before landing checklist complete, confirm. But the runway is too close and the speed is excessively high. An aircraft with a long flare lands beyond the normal touchdown zone and overruns off the runway surface. Let's return to the ill-fated turn of the Boeing before the short final. If this arc was extended into a straight line in a horizontal plane, it could be understood that at this stage the crew must extend the landing gear. In this case, the resistance of the aircraft increases sharply and the speed drops. The ATC controller logically expected this, and pilots dropped the landing gear down only after the turn, losing several tenths of seconds. Why? In interviews with crew members, there is no answer to this question. When trying to contact the pilots through the company, the answer was received. What do you want from us? The pilots have already been fired. Whoa, that's what we didn't expect from the management. And this is despite the fact that the investigation has just begun. The flight data recorders and all related materials the airline's management has not yet seen. And what helps solving the mystery? A careful study of the personal data of each pilot. Both the captain and the first officer received Boeing training recently, although before that they had huge flight experience. Experience gained by flying on Soviet aircraft. What's the difference? On Soviet aircraft, the landing gear can be extended only in straight level flight, which means in flight without g-forces, which means not in a turn, because there is always an overload in a turn. The formula for the g-force value in a turn is simple. As aerodynamics tutor at the flight school told us, physics grade 8. Could the controller know about this? Could any of the members of the accident investigation team have guessed it without being an airline pilot? The seconds of turning to the runway by pilots with no Soviet planes experience would be used to extend the landing gear, and the speed by the end of the maneuver would be correct. No fuss, no time pressure, normal approach, normal landing. Of course, the crew had the opportunity to go around, and they had to do that. But the accusatory bias breeds a superficial investigation and kills the main task, the prevention of future accidents. For sure, in this case it is good that such a risk factor as the negative impact of the experience of flying on Soviet aircraft is a typical example of dissolving risk factors. In one of the following videos, we'll talk about another such factor, the consequences of the transition of aviation from analog gauges to glass cockpit or complex electronic flight navigation instruments. This video also uses footage of the MD-83 incident in the same place, Zhulyany airport. There is no coincidence. Pilots were blamed for it, but thanks to the involved investigators from the Ukrainian Airline Pilot Association, a completely different reason was proved. This will be in our further videos. And now, as promised, we'll talk about the effect of ecological rebound. We'll take, for instance, Gretta Thunberg's ocean voyage to the United Nations Climate Summit in New York. She chose a sailing yacht over an airplane because airplanes are believed to be one of the main sources of greenhouse gas emissions into the atmosphere. But in order to ferry the 18-meter yacht back to Europe, 2 members of the yacht's crew flew from there to New York, which of course questioned the effect of Greta's supposedly purely ecological journey. And here is another fact that deserves attention. UNESCO is sounding the alarm about a catastrophic decrease in the amount of fresh water on the planet. The lack of fresh water will soon lead to a global environmental catastrophe. Modern aircraft engines provide almost complete combustion of jet fuel. With sufficient completeness of combustion of hydrocarbons, the products of combustion are carbon dioxide and water, and the combination of the above-mentioned elements gives fresh water. Chemistry lesson, grade 8.